Okay, so over the last two videos, we've looked at reducing balance loans, and we've looked at them in two different ways. We've looked at setting up a recurrence relation to model the reducing balance loan, but we know that that's a bit limited because there's no rule to get directly to the nth term. If we want to know the value of the loan after 30 years, we would need to recur the recurrence relation to the 30-year point, and if it was monthly repayments, that would obviously be a lot of recurrence. We've then looked at an amortization table, which allows us to model the loan. Again, it could be a big table if there's a lot of repayments, but that can be easily enough generated with a spreadsheet. However, we won't be looking at situations to that extent. You'll just need to be able to find missing values in a table. The third way to analyse reducing balance loans is to use the finance solver application in your CAS calculator. And this is going to allow us a lot more flexibility. So we can deal with a lot more complicated problems and a bigger variety of problems using the finance solver. So finance solver in the TI Nspire CAS is menu 8.1. And when you bring that up, you'll get this table, which you can also see screenshotted in the notes. And there are a number of quantities here that need to be filled. Okay, so the first one, N, is the total number of repayments to be made. Okay, so if it's monthly repayments for 3 years, that would be 36 repayments, So you need to actually work out how many repayments. I is the annual interest rate. So you don't need to adjust the interest rate if the payments are being made monthly or quarterly. The CAS will do that for you. You just give it the annual or nominal interest rate as a percentage. So you don't, if the interest rate is 8%, you don't write it as 0.08, you literally just type 8. PV is the principal value, or sometimes also known as the present value of the loan. Okay, those are fairly interchangeable, they both work. So what's the loan worth at the moment? I'll talk a little bit more about the positive and negative in a minute. The payment is the value of each payment. So if you make monthly repayments, how much are you repaying? Future value is the amount owed on the loan after N repayments have been made. Okay. And again, I'll talk about the positive and negative in a bit. And then PPY and CPY, which are sort of getting down beyond the screen here. So PPY and CPY. Oops, sorry. Are these two here. That's the number of payment or compound periods per year. Okay, so if it's monthly repayments, that will need to be 12. Okay, if it's quarterly repayments, that will have to be 4. And in Further Maths, we'll always be dealing with problems where those two things are the same. The repayment period and the compounding period is always going to be the same. So PPY and CPY will need to be adjusted, but they should always be the same value. And then the last option, payment at end, that's really just indicating that it'll always be end for you. It's really just indicating that we are making the repayment after the interest has been calculated. Okay, so those are the things that we need to be able to fill in any given problem. And then if one quantity is unknown, you leave that quantity blank, and then once you've filled everything else in, you go to that blank cell and you press enter, and it will calculate that cell given all the other cells. So if we have a look at the example that you can see in the screenshot above, shows a $20,000 loan. So the present value, or the principal value, is $20,000, charging 6.5% interest compounded monthly, and the loan is being paid off over 5 years. So 5 years of monthly repayments, 5 times 12 is 60. So that's why N is 60. Interest rate, I, is 6.5. Present value or principal value is $20,000, and the payment is what's being calculated. So leave that blank. We want to repay the loan over those 5 years, so we want the future value after those 60 repayments to be 0. It's monthly, so payments per year, compound per year, are both 12. So if the way I'll show you how that's done, so if I put that information in, so N is 60, interest rate is 6.5, principal value is 20,000, payment is what I'm trying to work out, so I'm going to skip over that for a minute. I want the future value to be 0. Payments per year is 12, compounds per year is also 12. You'll notice that when you edit PPY, it automatically changes CPY to match. which suits us because that's what we want. And then we tab to the, so I'm using tab to move between cells. It's easier than using down. Sometimes, particularly if you've got an older operating system on your CAS, down can open the drop-down menu rather than, and then it gets a bit complicated. So tab, oh sorry, I went past it. So back to payment, which is the value I want to calculate. And with everything else all set in the right positions, I then press enter on the payment cell, and it will calculate what the payment should be to match everything else. So in this case, the payment is $391.32. Now you'll notice that it's negative. And this is one of the most complicated things that we need to make sure that we get right when working with the finance solver. Okay, we need to get the positives and negatives right, and that's about the flow of the money. Okay, so basically, it's a loan. So I like to think about it as if the money is coming towards me, it's positive money. If it's going away from me, it's negative money. Sometimes you need to think about the future value slightly differently, but certainly present or principal value and payment. If it's coming at me, positive. If it's going away from me, negative. So this is a loan. I've borrowed that money from the bank. The bank gave me $20,000. So the present value is positive. Okay. The payments, I make those to the bank. That's money that goes away from me, so that's negative. Okay, so that's why it says negative 391. If you were answering a question, which is what would the monthly payment be, you don't say that the monthly payment would be negative $391.32. The payment would be $391.32. So it's about just being careful about interpreting that. Future value being 0 is obviously that there's nothing owing further. We'll talk a bit more about that over here. So if you think differently about the loans versus the investments, and obviously different things can happen, and the more we work through this topic, sometimes payments we might be withdrawing money or we might be depositing money, so we need to be clear about what's happening with that. And again, staying clear with the payment idea that if it's money I'm putting away from me towards the bank, then that's negative money. Money from the bank coming at me is positive money. So generally speaking, if it's a loan, the principal value is going to be positive because I'm borrowing the money and the money is coming to me. I'm going to then make repayments and they're going to be negative because that's money going from me to the bank. Now, the future value in a loan situation will either be negative or 0. Okay? So the future value sort of, if it's negative, it's because you still owe, as an individual, you still owe money. Okay, so in the case of a loan, as I'm working through the loan, repaying the loan, the future value will always be negative until I finally repay it, and then it's 0. Obviously, if the future value of a loan was positive, that would actually indicate that I've overpaid the loan and the bank owes me money. So in practice, that wouldn't happen, but in terms of your calculations, you can see that sometimes, and that's where you need to then think about adjusting your final payment. So you can think about the future value as being relative to you. So if that's negative money, if the future value is negative, it's because you still owe money. If the future value is positive, it's because actually the bank owes you money. And if it's 0, obviously it's being fully repaid. So in an investment, you put the initial value, the present value, the principal value into the bank. Okay, so it will be a negative amount in the finance solver. Now, depending on the investment, different things can happen. Okay. A loan, you're always trying to repay the loan. In an investment, you might be adding to the investment, so you might also have negative payments because you might be depositing money every month into your investment, or you might be withdrawing money out of the investment, so in that case they'd be positive. Okay, so this is probably a bit situational dependent. They can definitely be negative or positive. Might be 0 if you're just leaving the lump sum in there just to earn interest. The future value of an investment will generally be positive. Okay, because it's your money, it'll be positive, or it could be 0 if you've withdrawn the full balance and there's now nothing left. If you get a negative value, future value for an investment, that's because you've actually overdrawn the account and you now owe some money back to the bank. So in practice that wouldn't happen, but again, in sometimes looking at those little details in calculating the last payment, you might be looking at a negative value for an investment, and that's because that last withdrawal you made actually overdrew the account, so you then need to adjust what the last withdrawal would be. When you use Finance Solver to solve problems, it's a really a good idea to write down the values that you enter in the CAS. It makes it much easier to go back and check your work. Okay, If you've got time to do that in an exam, rather than having to work the problem again from the beginning, you can see what you did and you can check whether or not it's right. And it's just good strategy as well. It also, in a test and things, it will help your teacher to see where you are not understanding things and where you're going wrong. If you just write an answer, it's very difficult to earn any meaningful feedback from that, either from yourself or from your teacher. Okay, so let's just work through two examples here. Jeffrey borrows $15,000. So you'll find every time you open Finance Solver, it'll still have the numbers in it that you used last time. That's fine, you just edit them and change what you need. Jeffrey borrows $15,000 to purchase a motorbike. He plans to repay the loan with equal monthly repayments over 3 years. His loan charges interest of 8% per annum compounded monthly. Part A, find the monthly repayment. Okay, so let's think about what we need. So N is the number of repayments, and in this case he wants to make equal monthly repayments over 3 years, so that's 12 times 3, which is 36. Okay. Now in your CAS, if it's a bigger number than that and you're not sure what, you can't work out what 12 times 3 is, or as I said, if it's a larger number of things and it's a bigger calculation, you can in this N box actually just type 12 times 3, and then it'll work out when you tab to the next box. Okay, your interest rate was 8% per annum, so I will be 8. Your present or principal value, Jeffrey borrows $15,000. So he's borrowed that money, the bank has paid that money to him, that is positive $15,000. Payment we don't know, so I'm just going to delete that and leave that blank for now. Future value, he wants to fully repay the loan, so over the 3 years, so we want the future value after those 36 payments to be 0. It's monthly, so payments per year and compounds per year will be 12. Okay, so let's just write down what we've got. So our present value is 15,000. Our payment is the unknown. Our future value is 0. And payments per year, compounds per year is 12. Okay, and then we can tab back to our payment cell and press enter. Okay, so we find that the payment is negative 470.0, now nearest cent 05. Okay, so therefore the payment, so it's negative because Jeffrey is paying that money to the bank, but in terms of answering the question, the payment is $470.05. How much correct to the nearest cent does Jeffrey owe after 1 year? Okay, a couple of things here is when you make a payment, so the present value and the future value, they can have any number of decimal places because that's just a nominal number that's sitting in a spreadsheet that sort of doesn't really exist. The payment, you're going to have to make that payment to the bank, and so you're not going to be able to pay $470.04548 whatever cents, okay? So you should round this before you use any future calculations to the actual payment that's being made. Okay, so part B, how much correct to the nearest cent does Jeffrey owe after 1 year? Okay, so this time, N changes now. We're only interested in looking at after 12 payments. I stays the same, interest rate's the same, principal value is still the same, $15,000. He's now making the payments. So in payment, it's going to be negative 470.05, okay? This time we want to know what is the future value after those 12 payments. Payments per year and compounds per year, still 12. Okay, so now I'm going to leave my payment number in the cell. I'm going to go up and adjust the N value, to be 12. Everything else is okay, and then we're going to click on future value. Alright, and so we find here that the future value is negative 10392.90. So it's negative because money is still owing after only 1 year. So that's money that Jeffrey still owes. How much correct to the nearest cent does Jeffrey owe? So he doesn't owe a negative amount. The amount that he owes. So after 1 year, there is $10,392.90 still owing. What is the final payment that Jeffrey must make to fully repay the loan after 3 years? Okay, so we've seen in the last two videos looking at both the recurrence relation and the amortization table, rarely does it work out perfectly that the loan's exactly paid off over those 3 years. So what we want to do here is calculate, this time, I'm just going to delete that, this time we want to look at over the 3 years, so 36 months, everything else is still the same, making those payments, what is the future value if I actually make 36 payments of $470.05? And it'll be slightly off usually, okay? So what we're looking at here is we've used all the same values. N has gone back to being 36, I is 8, present value or principal value is 15,000, payment negative $470.05, future value is what we're working out, and payments per year and compounds per year still 12. Okay, and what we find is the future value is negative, no, not negative, sorry. The future value is 0.18. Okay, so the fact that the future value is positive in a loan, a positive amount means that, you know, that's money owed to me, not money owed to the bank. So actually I've overpaid the loan by 18 cents. Okay, so this means that the loan is overpaid, overpaid by 18 cents. Okay, and so therefore the last payment, the 36th payment, will actually need to be 18 cents less than a normal payment. So a normal payment was $470.05, so we need to take off that 18 cents. So that is going to be, what's that, 13, so $469.87, I think. You can, of course, sorry, let me go back to that, what did I say? $469.87. You can, of course, just press escape to get out of your finance solver to go back to a calculator screen. So you can actually type that in if you need. Let's just check that I'm right. Yes, good. Okay, so menu 8.1 to open up Finance Solver, it'll still have the numbers in it that you had previously. Some people make the mistake here when they're calculating the last payment of actually calculating after 35 payments how much is still owing and saying, oh, the last payment needs to be that. Okay, but the problem is after 35 payments, the money will then sit in the bank for another year and earn interest for another year. So there'll be more than $466.76 remaining at the end of that next year when you next make a payment. So you still have to work out what happens after 36 regular payments. 36 regular payments, and then adjust your final payment on the basis of what you learn from that. Okay, Part D, find the total cost of repaying the loan, correct to the nearest dollar. Okay, so total repayments. We've made 35 payments of $470.05, plus we've made one payment of $469.87. The other way that you can work that out, that's actually the same as doing 36 lots of the regular payment, and then just subtracting your 18 cents that you, sorry, not 18, 0.18, that you know that you ended up overpaying. So you can actually do it that way as well. Both of those will give you the same answer. So just press escape here and calculate it. I'll show you that they give you the same. So 35 times 470.05 plus 469.87, which I could have copied down from above. Okay, so that's the total payments. Let's just check if I did it as 36 lots of 470.05 and then minus the 18 cents that was overpaid, we get the same amount. Okay, so your total repayments is $16,921.62. So find the total amount of interest paid, correct to the nearest dollar. Okay, so the interest is going to be your total payments, interest is going to be your total payments, which was $16,921.62, minus the amount that was borrowed, which was $15,000. So if we subtract $15,000 off that total payment, we can see that over the course of 3-year course of this loan, we've paid interest of $1,921.62. Okay, let's have a look at another example. Example 2. Clint and Andrew are taking out a home loan of $250,000. Their bank charges interest of 5.1% per annum, compounded monthly. Part A. If they make monthly payments of $1,300, find how many monthly payments will be required to fully pay the loan. So this is N is the unknown quantity here. Okay, so in this case, N is what we don't know. The interest rate is going to be 5.1%. The present or principal value is $250. Now they're taking out a home loan, so that's money the bank is going to give to them. So it's positive $250,000. They then make monthly repayments. So our payment in Part A, monthly repayments of $1,300, so negative $1,300. They're paying that money to the bank. Future value, we want to fully repay the loan, so we want the future value after however many payments it is to be 0. And payments per year and compounds per year, again it's a monthly, so 12. Right, let's put that information in. So we don't know n, let's leave that blank. 5.1, present value is 250,000, payment negative 1,300, future value needs to be 0, and we want to work out how many payments do we have to make for that to happen. Okay, so 400.83. Now I would always round this to the nearest whole number. If you round down to 400, there's still going to be a lot owing because you've nearly got a whole extra payment that needs to happen. 0.83 is closer to another payment. So you'd be better to make it 401 payments, and then you're going to adjust your last payment will be less than $1,300. Okay, but you want to go, you just want to round to the nearest whole number so that you're making the smallest possible adjustment to that last payment. If you were to round down to $400, 400 months, I'm sorry, then your final payment would actually be nearly double a regular payment because you've still got another 0.83 of a year, technically. You're still to 0.83 of a month, sorry, technically, that would still be owed. So you're going to have a really big final payment, whereas if you round up to the nearest whole number, which would make it 401, you're going to need to adjust your final payment by the smallest amount. In this case, you'll adjust it down. It's okay to adjust it up. There's no problem with adjusting the payment up, but you don't want to be adjusting it up by, nearly having to double the payment again. So, in this case, we're going to say n is going to be 401. Okay, so it specifies in the question to correct the nearest month, and you'll see what I mean. So therefore, it's going to be 401 months. Just quickly, let's have a look. If I'd made this 400, if you then have a look at what the future value is, after making 400 payments, you still owe another $1,085. So, if you're going to make only 400 payments, that last payment would need to be $1,300 plus $1,085.24. So that's a massive last payment. So instead what you'll do is we round to the nearest whole number. It's 401 payments. Future value will be, we've overpaid by $210. That's $210 is a much smaller adjustment to make to your payment than another sort of $1,000. Okay, so instead the last payment, the 401st payment, wouldn't be $1,300. It would be $1,300 minus $210.15. Okay, so sort of 1,100-ish. Find how many monthly payments will be required to fully repay the loan. Okay, so we're done there. Clint and Andrew decide they only want a 30-year loan term. Correct to the nearest cent, so let's just have a look. So 400 months, just escaping out of there. 400 months, if we divide that by 12, that's about 33 years. Okay, so they've decided that they only want a 30-year loan term. Correct to the nearest cent, what do the monthly repayments need to be if they are to fully repay the loan in 30 years? Okay, so this time, n is now going to be 30 times 12, okay, which is 360. Again, you don't need to work that out. You can just type 30 times 12 into the finance solver. Your interest rate is still 5.1%. Your principal value or present value is still 250,000. Positive, it's borrowed money. Payment is what we want to work out if we want to exactly repay in 30 years. So we would expect a higher payment than $1,300 because we want to repay the loan quicker. So that's going to necessitate higher repayments. We want the future value to be 0 because we want to fully repay the loan. Payments per year, compounds per year, still going to be 12. Okay, so let's make it 360 for n. Interest rate still 5.1. Present or principal value still 250,000. Payments what we want to work out. We want the future value to be 0. Okay, let's tab back around to payment. Okay, so we need the payment to be 1,003. So it should be the finance solver said it's negative 1357.37. Okay, and so therefore the payment needs to be $1,357.37. Okay, so yes, more than previously, and that's because we want to repay the loan quicker. Part C, how much interest do Clint and Andrew save by going with the higher monthly repayments? Okay, so let's work out the Part A total repayments. Okay, sorry, Part A, we'll do that. I'll come back to that. I'll do Part B first because I've got those numbers in the CAS already. And the Part B total repayments. Okay, so we need to be a bit precise here. So they're going to make, we need to work out the final adjustment. So we can still do, as we did in the previous example, we can say they make 360 payments of $1,357.37, but let's work out what happens if they actually do that and make that adjustment. So, I've rounded the payment value to the actual amount they'll repay, and I then want to work out, well, what's the future value if they make 360 payments of that? Okay, and it's negative $3.76. So if negative means that I still owe that money. Okay, so I've underpaid by $3.76. Sorry. So we're going to need to add the last payment. We'll add that $3.76 on. Okay, so the total payments here. Let's just do the calculation. 360 plus 1357.37 plus the extra $3.76, which we would add on to that last payment. So we would actually make 359 payments of 1357.37, and the final payment would be 1357.37 plus $3.76. But we can calculate it this way instead. So 1721.13 would be the total. Sorry, that's not right, is it? It's nowhere near enough. We're paying off a $250,000 loan. That should be a multiply there. Let's try again. So that is $488,656.96. Okay. Now let's go back and do part A. So menu 8.1, back to my finance solver. So in part A, we were making 401 payments. Same interest rate, same principal value. The payment was negative $1,300. We'll work out the future value. Okay, so future value is positive, means we've overpaid. Okay, so again we can think about, okay, we're making 401 payments of $1,300, but in doing that we end up overpaying by $210.15, so we take off that $210.15. Okay, so if we work that out, 401 times 1,300 minus $210.15. Okay, so total repayments here are $521,089.85. Now, sorry, I'm just going to leave myself some more room because we actually are interested in we want the interest. Okay. Alright, so this means that the interest is going to be 521,089.85 minus the 250,000 that we borrowed. So it's going to be that amount minus the 200,000. So the interest we're paying here is $321,089.85. And here the interest in part B is going to be this total amount minus the amount that was borrowed, and so that is, so I've got these numbers here again, so let's get this number up here, minus the 250,000. Here we paid $238,656.96 in interest. So how much interest do they save by paying the loan off quicker? So the interest saved is going to be the bigger interest minus the smaller interest. So let's do that. This number here minus this number here. They're going to save $82,432.89. Okay. So you see these are realistic numbers for a home loan. Maybe at the moment it's a high interest rate, but realistic. So, over a 30-year period repaying your loan, you pay a lot of interest. And look how, just by paying an extra $57 a month or so, they're going to save over the life of their loan over $80,000. So, the more that the quicker you can pay off your home loan, the better that is. All right, so the work today is from exercise 9C, questions 1 to 6.